Welcome. In this lesson, we're going to talk about Boolean expressions in Java. So let's get started. For this lesson, we've got three learning goals, and the first two should be fairly familiar to you already from past coding experience, so we're going to go through them fairly quickly, which is being able to use the relational operators in Java to write Boolean expressions. So that would be like less than and greater than. And also that you can use logical operators, which would be and, or, and not. What will probably be new to you, however, is De Morgan's laws, which will allow us to identify equivalent Boolean expressions and simplify them. On this slide, we've got Java's relational operators, and very likely you have seen these before, even if it was in a different language. So rather than talk them through, what I'd like you to do is pause the video, spend a little bit of time studying the table, and then don't move on until everything you see in front of you makes sense. On this slide, we've got Java's logical operators, and the logical operators and an or are used to combine two or more Boolean expressions. So for example, for and, if we have two Boolean expressions, the and will evaluate true if both of the expressions are true. Whereas with or, it will evaluate true if just one or the other of the expressions is true, and then not negates a Boolean expression. On the next few slides, we'll look at some examples of how this works, so if it's not crystal clear now, hopefully it will be in a couple of minutes. So the Boolean expression that you see in front of you uses an and what we'd like to do is determine if the overall expression is true or false. But there's actually two Boolean expressions, one on the left and one on the right, and both of them must be true for the overall and to evaluate as true. So starting with 5 greater than 2, that is true. 5 is larger than 2. And then moving to the right, 6 divided by 3, well, that equals 2, not 3. So we have a true and a false, which makes the overall expression false because for and to evaluate true, both the left and the right must be true. In this second example, we see an or. And with or, one or the other Boolean expressions must be true. So starting on the left side, not true means the opposite of true. Well, that's false. And then if we move to the right side, we have not false, and not false evaluates to true. The overall expression, however, is true because all we needed was one of the two to be true. In this third example, we also have an or. So again, we need one side or the other, one of the two Boolean expressions to evaluate to true. Well, 7 is not less than 2, so that's false. So the only way the overall expression could be true is if the right side is true. 1 plus 2 does not equal 3 is absolutely false as well because 1 plus 2 does equal 3. So for this expression, the overall result is false. In this example, we'd like to know what values of x would make the expression true. And so notice that we have a couple of ands happening here. So I think we'll start on the left and use those parentheses to help dictate our order of operations. And so the first expression says x is bigger than 0 and x is less than 10. Well, the only numbers that are both bigger than 0 and less than 10 would be the numbers 1 through 9. And then moving to the right side, we want basically anything for x except for 5. So the overall values of the expression that would make this true will be 1 through 9, excluding 5. This example is really interesting because if you notice out in front, there is a not and a set of parentheses that encloses the entire rest of the expression. This was really intentional and quite honestly is what I want to talk about in this lesson. How do we deal with this? So we could probably think in our heads as to what would make this expression true, but with that not out in front, we end up having to think really hard about it. And so perhaps a better approach would be to deal with that not out in front and actually create a simpler expression. In order to understand how we can deal with this not in front of all of our logic, it's helpful to think about algebra class. And in algebra class, sometimes we have a negative sign in front of a set of parentheses. And in algebra, we would typically distribute that negative through. Well, in logic, the not, the exclamation point, is very much like the negative sign, and we can distribute it. The trick is making sure we distribute it to all the right places, because that not will negate every single piece of logic in our expression, starting with the greater than. And the opposite of greater than is less than or equal to. Then we apply the not to the or, and the opposite of or is and. And finally, we apply the not to our less than or equal to, and the opposite of less than or equal to is greater than. So this is the resulting expression, x less than 2 and x greater than 0. And it's much easier to evaluate because the only numbers that are bigger than 0 and less than or equal to 2 are the numbers 1 or 2. So this can be used to simplify your logic, and the process we use is called De Morgan's law. And De Morgan is a mathematician who did a lot of work in logic. All right, time for you to try applying De Morgan's law. What I'd like you to do is pause the video and try this problem. Try to simplify it, try to distribute the negative, and there's a couple of them to do. And when you're ready, resume and we can check our answers. All right, so what I did is I started with the not out in front, and I first distributed it to the equal equal, and that turned into a not equal. So that's why you see that we have x not equal to 2 in our answer. Next, I distributed the not to the and that became an or. And then finally, I distributed it to this inner expression, not and the quantity x greater than 4. Well, in this case, it's really simple because not cancels itself out, just like a double negative in math class, giving us the resulting expression, x not equal to 2 or x greater than 4. So that's it. After watching this lesson, you should be able to use relational operators and write Boolean expressions in Java. You should be able to construct Boolean expressions using the logical operators and, or, and not. And what should be fairly new to you is that you can apply De Morgan's laws to identify equivalent Boolean expressions.